Hello everyone. In today's lecture, we are going to wrap up our discussion on the topic of while loops. Few quick announcements before we get started. As we keep making progress in this semester, the level of difficulty for projects is going to constantly increase. I would strongly encourage all of you to find a project partner. You can head to the Discord channel if you're still looking for a project partner. I'm sure that some of you have been able to get help for this course via office hours. I would like to remind all of you that there is a thank you form on the course website class surveys page. You need to click on tools and class surveys in order to access the thank you form. Please consider filling out the thank you form if you'd like to thank a specific TA or a specific peer mentor. I'm sure that will bring a smile onto their face. Let's get started by talking about the learning objectives for today's lecture. So far in CS 220, we have covered the concepts of expressions, variables, functions, conditionals, and while loops. When you think about combining all of these concepts within a program, there could be infinite such possible combinations. Practically, programmers tend to follow specific design patterns when it comes to creating programs. In today's lecture, we'll be covering examples of such design patterns. Then we are going to learn about break and continue statements, which will enable us to disrupt the normal flow of execution of a while loop. Finally, we'll be covering nested loop examples with break and continue. The reading for this particular material is Chapter 7 of Downey book. I would like to let all of you know that Chapter 2 of Zweigart book offers a refreshing new perspective on all the topics that we have covered so far. That would be a good reading for you to cover for the purpose of exam 1. Let's get started by talking about the 5 paragraph essay format, which most of you should be familiar with. When you want to write an English essay, you typically write one introduction paragraph, then three main body paragraphs, and finally one conclusion paragraph. Somebody who's trying to read your essay in order to evaluate it might not follow the same ordering of your paragraphs. Typically, they tend to read the introduction paragraph first and directly jump to reading the conclusion paragraph to see what sort of conclusions you're drawing from your essay. Then they'll go back to your three main body paragraphs to verify whether your essay is leading towards those conclusions. There are a lot of similarities between reading and writing essays and reading and writing code. Let's consider this code snippet for example. When you ask a programmer what a specific piece of code is doing, they can follow a couple of options to answer such a question. Option number one is walking through the code in order to figure out the output that that particular code will produce. For instance, in this example, we are initializing a variable I with a value 1. So you can draw a box beside the variable I to keep track of its value. Then you have a while loop. The condition of the while loop is I less than or equal to 30. 1 is less than or equal to 30. So you're going to execute the first iteration of your while loop. Inside the while loop body, you're initializing a variable called n with a value of I into 2. So n is going to hold a value of 2. You can imagine drawing another box to keep track of the variable n's value. Then you're calling the print function to display n. So the display output is now going to contain 2. The last line of your while loop body is incrementing the value of I by 1. So I is now going to get updated to 2. Then you'll go back to executing the while loop condition one more time. 2 is less than or equal to 30. So you're going to proceed with iteration number 2, where you'll turn n to hold a value of 4 and you're going to display 4 to the output. You can imagine continuing this trace in order to determine the rest of the output of this particular program. Let's talk about option number 2. Option number 2 has to do with unrolling the loop. What exactly do I mean by unrolling the loop? An experienced programmer will focus only on the lines of code where the loop condition variable is being updated or is being subject to a condition. So in this particular example, that would be the statements I equal to 1 and the condition I less than or equal to 30 and the increment statement of I plus equal to 1. Then they will unroll the loop by observing that this particular loop will run for the values of 1 to 30 for the variable I. Once they have unrolled the loop, they are going to focus on the rest of the loop body. So the highlighted code here, which is marked with red dotted box, is not really a block of code, but that's the part of the while loop body which is going to be repetitively executed after you have unrolled the loop. So they'll observe that these two lines of code will be run 30 times. After that, it's very easy for you to determine that this particular program is going to give the output values of 2, 4, 6, etc. up to 60, correct? So that is the conclusion that they draw by going through this unrolling process. Option number 2 is so much easier for you to go through in order to determine output of any given code snippet in a quick manner. So let's talk about various design patterns that programmers tend to follow while creating program. Often, while loops are used for doing some action n times, where you use the counting use case for while loops. Typically, you'll see two different types of while loop examples for this particular design pattern. First option is going to be option A, where you're initializing your while loop condition variable I to a value of 1. Then you're going to execute the while loop until your condition is I less than or equal to n, and your increment inside the loop body is going to be by a value of 1. So the option B for running something n times is to start with an I value of 0. Instead of having your loop condition as I less than or equal to n, now you're going to have your loop condition as I less than n. And finally, you'll have the increment as the same increase by one value. You can imagine filling in this box here with any kind of specific where you want to repeat certain action for certain number of times, where the number of times is given by capital N. The option A loop will run for the values of 1, 2, 3, etc. up to n if you unroll it. Similarly, if you unroll option B, you'll observe that option B's loop runs through values of 0, 1, 2, etc. up to n minus 1. Why is the last value n minus 1? That's because our condition here is I less than n. You need to be really careful about off by 1 errors with respect to loop conditions. So focus specifically on the operator that is being used as part of the Boolean expression, and then determine what is the maximum possible value that you can have for the loop condition variable when you unroll the loop. Let's talk about design pattern 2. Design pattern 2 has to do with specific data analysis for the given set of data. Let's say that you have a table which contains entries for all the states, and it shows corresponding population for each state in the United States along with the area and few other details. You can imagine having specific functions defined as part of a certain module, which is going to give you access to the number of rows in this particular data set. Let's assume that we have a count underscore rows function defined, which is going to give you the total number of rows within the table. Let's also assume that you have a get underscore population function, which is going to take as argument the index value, which is nothing but the row position of the data that you're interested in. For instance, if you want the population for Wisconsin state, your index is going to be 0. In programming world, index or position always begins at 0. You're going to get used to that pretty soon. Let's say that you want to access the population data for California, then you're going to have to provide 1 as the argument for your get underscore population function over here. Given these combinations of functions, we are now going to update the counting pattern for our while loop to take into consideration the count underscore rows function and get underscore population function. The while loop condition will take the form while I less than count underscore rows. Observe that we are starting at index 0, hence the condition here is less than, because you want to run the while loop through every index position here, which would be starting at 0 and it will go up to n minus 1, where your data set has n rows. Inside your while loop body, you can imagine calling the get underscore population function by passing every index in order to get the population corresponding to that state. You can imagine filling in specifics here. Let's say that you're trying to compute the total population of all the states within United States. Then you can have an appropriate code that will replace this box over here. So this is going to be design pattern number 2. Let's move on to talking about design pattern number 3. A lot of programmers design modules which have couple of functions in the form of has underscore more and get underscore next. What is the purpose of this particular design pattern? Let's say that you do not know how much data you have left to process, or let's say that your data set keeps getting updated and your program needs to handle new data all the time. So then you'll be using this third design pattern, which uses the has underscore more function to verify whether there are more data entries for you to process. You can imagine this function returning a Boolean value of true when there is more data to process, and it's going to return a Boolean value of false when you're done processing all of the data. Then the get underscore next function, as you can imagine, will retrieve the next line of data from your table or whatever form that you use to store your data. And once you get the data into a variable data, you can imagine processing that by filling in some specific as part of your while loop. Those are all the design patterns that we are going to cover as part of today's lecture. I'll wrap up this video here. In the next video, I'll be going through problem 1 and problem 2 from today's lecture worksheet. I would strongly encourage you to go through problem 1 on your own before you proceed watching the next video.